Renewable energy sources naturally replenish themselves, offering a sustainable energy alternative. Solar energy harnesses sunlight, using photovoltaic panels to generate electricity. Wind energy converts kinetic energy from wind into electricity using wind turbines. Hydropower utilizes the energy of flowing water to generate electricity. Geothermal energy taps into the Earth's internal heat to produce electricity or heat. Biomass energy uses organic matter to generate heat or electricity. Photovoltaic PV cells harness solar energy by converting sunlight directly into electricity. When photons strike the PV material, they excite electrons, generating an electric current. The efficiency of solar panels varies, depending on the materials and technology used. Solar energy conversion relies on the photoelectric effect within semiconductor materials. The generated electric current can be stored in batteries or directly fed into the power grid. Concentrated solar power, CSP, systems employ mirrors or lenses to focus sunlight onto a small receiver. The concentrated heat is used to produce steam, which drives a turbine to generate electricity. CSP is particularly effective in regions with high solar irradiance. Mirrors or lenses are key components in concentrating solar energy. Wind turbines convert the kinetic energy of wind into electrical energy. Wind flowing across the blades causes them to rotate. The rotation of the blades turns a generator inside the turbine's nacelle. The amount of electricity generated depends on wind speed. The amount of electricity generated also depends on turbine size. Electrical energy is then transmitted for distribution. Offshore wind farms are situated in bodies of water to leverage higher and more consistent wind speeds. These wind farms are capable of generating substantial amounts of electricity due to the consistent wind resource. Installation of offshore wind farms presents significant engineering challenges. Maintenance of offshore wind turbines requires specialized equipment and expertise due to the marine environment. Offshore wind farms can have environmental impacts on marine ecosystems. Balancing energy generation with environmental stewardship is crucial for sustainable offshore wind development. Hydropower harnesses the potential energy of water stored at a height. As water flows through the dam, it turns turbines connected to generators. The rotation of the turbines drives generators, producing electricity. Hydropower provides a reliable source of energy, though with potential ecological consequences. Run-of-river hydropower systems divert a portion of a river's flow to power turbines. Water flows through a channel or penstock to power the turbines. Run-of-river systems have a smaller environmental footprint compared to traditional dams. Energy output depends on the river's natural flow rate. Geothermal energy utilizes the Earth's internal heat as a source for generating electricity. Geothermal power plants extract steam or hot water from underground reservoirs. The extracted steam is used to drive turbines, which in turn generate electricity. Geothermal energy provides a consistent and reliable source of power. Geothermal heat pumps leverage the Earth's consistent subsurface temperature for building climate control. These systems circulate fluid through underground pipes to absorb or dissipate heat. In winter, the fluid absorbs heat from the warmer Earth, transferring it to the building. In summer, the fluid dissipates heat into the cooler Earth, providing cooling for the building. Geothermal heat pumps offer energy-efficient climate control by utilizing a renewable energy source. Biomass energy is generated by burning organic matter, including wood, crops, and waste materials. The combustion process converts the chemical energy stored in biomass into heat or electricity. Biomass is a renewable energy source, as organic matter can be replenished over time. Unsustainable biomass practices can lead to air pollution and deforestation. Biogas is produced through anaerobic digestion, a process where microorganisms break down organic matter. Anaerobic digestion occurs in the absence of oxygen, facilitating the decomposition of organic waste. The primary output of anaerobic digestion is biogas, which consists mainly of methane. Biogas can be utilized as a fuel source for heating purposes. Biogas can also be used for electricity generation. Furthermore, biogas can be refined and used as a transportation fuel. Tidal barrages harness tidal flow energy by constructing a dam across a bay or estuary. As tides rise and fall, water flows through turbines within the barrage, generating electricity. Tidal energy is a predictable renewable energy source due to the consistent nature of tidal cycles. Tidal barrages can have significant environmental impacts on the surrounding ecosystem. Tidal stream generators are underwater turbines that harness the kinetic energy of tidal currents. These generators are less intrusive than tidal barrages, minimizing environmental impact. Tidal stream generators can be deployed in areas with strong tidal flows to maximize energy capture. Harnessing tidal currents offers a more environmentally friendly approach to tidal energy. Kinetic energy from tidal currents is converted into electricity by the underwater turbines. The consistent and predictable nature of tidal currents provides a reliable source of renewable energy. Energy storage is crucial for integrating intermittent renewable energy sources into the grid. Battery technology stores excess energy generated during peak production periods. Stored energy is released when demand is high, ensuring a consistent power supply. Lithium-ion batteries are a key technology for effective energy storage and grid stabilization. Pumped hydro storage uses excess renewable energy to pump water from a lower reservoir to a higher reservoir. This process occurs during periods of low electricity demand. When demand increases, water is released back down, turning turbines and generating electricity. This provides large-scale energy storage. Pumped hydro storage effectively balances energy supply and demand. The future of renewable energy relies on smart grids and advanced integration technologies. Smart grids utilize digital technology to optimize energy distribution and enhance grid reliability. Smart grids facilitate the integration of diverse renewable energy sources, creating a more sustainable energy system. Advanced energy integration promotes a more resilient and sustainable energy ecosystem.